I like to hand like this. Okay. Hello.
Professor.
Yeah, how are you?
Did you see my text message?
Not really. You actually, I don't receive text from that. Remember,
Oh my God! I thought you did that because when you sent the link last Saturday, I sent it back. I was in the hospital with my son. I couldn't attend. I thought.
I'm sorry to hear that. But are you? Is he doing okay now?
Well, we're just managing it. Oh, God is in control. And then the homework is being kind of difficult for me, and that work is kind of tough. I don't know.
You didn't see my message I sent about a tutor, Chris. I posted a message on Canvas.
I honestly, this week has been so difficult for me. I've been focusing on him than any other thing, so I wouldn't.
We still have time. We still have time. You still have from now till the 13th. I think 13th is the last day.
13th?
The last day for the semester. I mean, 13th of.
No, for the homework. I'm telling you, for the homework and all that. And the quizzes that is due tomorrow.
No. The quiz tomorrow. Actually, I moved it to next Saturday.
Okay, what about the homeworks? Because those homeworks
I moved two homeworks to next. I now leave.
Which ones are the one you moved? Because that 12 is difficult because of the calculator.
I don't have it offered. You have to check my announcement because after I moved it, I updated my announcement. So
yeah, the 12 because we need a calculator. I even I bought an app for the calculator. Then this morning my phone just crashed. I have to take it to the provider again. So
you can use this calculator I'm using online. Desmos. You can use that too, or you can use Excel. Remember the calculator I used for this class that I called Desmos?
Desmos?
Even we're going to use it today too.
Okay, Desmos. I already bought the app for I will check it too. Maybe I can use it on computer. Desmos.
But, so that messaging app. See, I don't send the text. I don't send text. I send it as a message, but it comes to you as text.
As a text. Oh.
When you reply, if you'll be thinking that you are texting me, but actually you're not.
Because he said we can reply back. He said you can reply back. So I send you a message that it was at the hospital. We were there for like 4 days on that Saturday. I couldn't focus.
Understand. So like after today, you can still continue. I moved 2 assignments to next week, and then the quiz. I move it to next week as well.
Oh, okay. Oh, thank you, God. I hope that 12 because I did 11, the 13. I have to do 14. The 14 has calculator too, and the 12.
I think I moved two homework to the next week. Then the quiz to next week.
Yeah, I hope it's 12 and 14 because the 12 have their calculator and the 14 has their calculator.
They all have calculators.
Oh, no. I mean like those TI 84 that we have to use. So if it's calculator, normal calculator, we use.
Because like I say, you can still use Desmos. Desmos is the one I use to teach you guys. It's online and it's free online.
Okay, I'll check it out. Thank you.
Let's begin now. Today I'm gonna show you something from your class. So like I was telling you, I moved the homework forward, 2 of them forward. This is my announcements for that. So with 12 activities and those homework have been there for like 3 weeks ago. So see, I moved stop on 13. So now instead of 15, now you say from 11 to 13. So
okay, from 11 to 13, you move from.
No, I do this Sunday, but for 14 and 15, I move to next week. Then
Yeah, that needs to be done today. So
it's 3, I move to next week as well.
okay.
Now for the reading material, like I always tell you, you guys can see my screen, right?
Yes.
For the material we need for today, you go to the files, and from file you can see it right here. So later you can, if you like, you can download it, and then it's lecture 9 right here. And we will also be using the table, statistical table. So that's what I want to show you on the website. So I'm gonna get off the website now, and we can begin. So I'm gonna log out from here and close it. Okay. So today we'll be looking at normal distribution. Normal distribution. Oops. Yeah. So Mary is Mary. Okay, Mary. All right. So I've already opened my handout, so I'm gonna show you where it is. All right, many continuous variables like height of men, temperature, they have a distribution that when you plot it for the entire population, it will give you a bell curve or normal. So when you plot them, like if you plot the height of adult men for the whole Maryland, it will give you a smooth curve that is like a bell. Or if you plot the cholesterol level of all adult men or adult women in Baltimore City, all of them, to also give you a smooth curve that looks like a bell shaped. So we call those distribution the normal distribution, or you can also call them bell shaped distribution, or even a Gaussian distribution, named after the the mathematician, the German mathematician that developed it. So now the normal distribution, this will lead us to the definition of what the normal distribution is about. So as you can see from my explanation here, the normal distribution is a continuous, symmetric, bell-shaped distribution of a variable. And those variables, I just mentioned a few of them: height of adult men, temperature, cholesterol levels. So look at how it will look when you plot it. All those variables, they will look like a shape like this. So you can say it's symmetric because half of this side is the same as half of the other side. And also, it is asymptotic in the sense that this part of the line curve appear to touch this side, but it never does. That's why we say that it is asymptotic. And also, actually the variables that deviate from this normal are very, very small. Many variables will have continuous variable follow this distribution. Now, let me give you some example of this one of the variables that follow it. How about this? The normal range of systolic blood pressure is 110 to 140 millimeter of mercury. Those of you in the nursing field knows that. Am I right or wrong? Those of you in the nursing field, am I right? That the normal systolic blood pressure is 110 to 140. Am I right?
That's correct.
Yeah.
How about this? Triglycerides. Normal triglyceride of a person's is between 30 to 200 milligram per deciliter. And also birth weight. Normal birth weight of a baby, around 6 to 9 pounds. If it is below 6 pounds, that means it's underweight. And it's above 9 pounds, it's overweight. Am I right? Or wrong?
You're right.
So these are a few examples of things that follow normal distribution. So now we can look at some of the properties. A normal distribution is a bell-shaped, a normal distribution curve is bell-shaped. See, look at the curve, you see, shaped like a bell. If you remember in the old days when we have a church bell on Sundays, see that you see the shape, a ring. So, so now the second property is that the mean, median, and mode are equal and are located at the center of the distribution. If you look at this curve, see this line here represents the mean, median, and mode for any normal distribution. See, mean equals to median equals mode, and they are located at the center of the distribution. Okay. Another one is that a normal distribution is unimodal. It has only one mode. And if you look at the chart here, you can see that it has only one mode. See, the mode is at the center. Remember when we did mode, the number that occurs most often, or you can say call it the number that has the highest frequency. See, has only one mode. Okay. The third one is this. The curve is continuous, and that is there is no gaps. See? Now, because they are plotting all the members of the population, it will give you a smooth curve, no gap. See? No gap, like like a break. Yeah, like if you're not plotting the entire population, it might give you a dip, like But if you're plotting the entire population for that particular variable, it will give you a smooth curve like this. Yeah. Now, the curve never touches the x-axis. Sure, this is the x-axis right here. And you can see that it doesn't touch it. It gets closer, but never touch it. Then the area under the normal curve is equal to 1 or 100%. Like I explained, this side, the left side is 0.5, the right side is 0.5. So that we have the total area as 0.5, 0.000, that's 0.5 plus for the right side here, the right half, we also have 0.5000, and that will give you equals 1. From Miss Owotutu, you there, right? You there? Miss Owotutu. Hello, Madam Owotutu, are you there?
Yes, I'm here.
So I'm about to show you the decimal. Say it's just 0.5 plus 0.5. You can see it from this calculator from here. That Davis. Okay, just for me. Let me put in this name of this student. Davis Morgan. Okay. So this is decimal calculator right here. It is see, you can see the link to that calculator, decimals.com/scientific. So you can see that 0.5 plus 0.5 equals 1. See? Please, can you mute yourself, please? So that's what they found. They say that the total area equals 1. So with this, we can let's see how we can calculate the areas of the normal distribution. Sorry, a normal curve. That is area under the normal curve. But before I do that, does anybody have a question in what I have said so far? Any questions?
No question.
Okay. Now let us see how to calculate the area under the normal curve. This calculating the area under the normal curve, another way of saying it is finding the probability given a z. Z is what we use to represent the normal curve or the standard score. So let's do the first one. I'm going to move this to the next page so that we have more room. Okay. Right. So the part A says, it says here, find the area under the normal curve which lies to the left of z.94. When you find the area under the normal curve, the first thing you do is to draw the chart. Solution. You can see this very well, right? Hello?
Yes.
first thing you do is to draw the charts. Let me make this bigger. Yeah, make it 16. Draw the chart. But let's see. The chart is I'm gonna draw it from here. Okay. The chart here. Then I'm gonna put the line for this. Now, you know, if I'm using a pencil, hand drawing, it is much faster. But we're not in the classroom, so we do the best we can. Okay. All right. So remember, I told you that this is the center that represents the mean, and the mean is 0, always 0 for this, for a standard normal distribution. Okay. Now, looking for this area, it said to the left of z.94. Remember, I told you that half of this is 0.5, and the other half is 0.5. So 0.94 should be anywhere on the right side because it is positive. Okay. So 0.94. And you put the line to show that area that we're trying to find. Okay. This side presents 0.94, and it says, hold on, let me move it a little bit. See, and it says to the left of it. That means say this 0.94. You see to the left of, so everything this way are to the left of 0.94. So what you do is to, excuse me. So you shed everything to the left of it. So the shedding part is what takes time, you know, because we are not using we're not writing on the board or using a pen and paper. So, but you know, like I say, if you're using a pencil and pen on paper, it will be very fast to shed it, and then you know, we got this. But we try our best. Always, what we can do to try our best. So the shaded area represents to the left of 0.94. Okay. 0.94. So this the whole of this shaded area is 0.94. Let me put one more line. Okay. One more. Okay. That's it. Okay. So this is an area where it says to the left of 0.94. So the area you're looking for now. So the area becomes whenever it's on this way, remember, half of this is 0.5 and another half is 0.5. Now, before I do this example, finish this one, I want to show you the table we'll be using. You know that there are 3 different kinds of table of normal distribution. This one is table 4. We're not using it today. We used it last time. This is the table we're using, table 5. This one is not cumulative. So it doesn't matter whether the z is negative or not. It doesn't matter. Negative means to just to let you know that it's on the left side. So this is the one we'll be using for this class. There are other tables that are longer than this. Those ones have their own rules. So to use them, you have to learn their own rules. But if you use them well, you will get the same answer. This particular one have a different rule, and those rules I'm going to explain to you in this class. Okay? Hello? Hello?
Yeah, we are with you.
Yes.
Now, so based on this table, it says here, let's say, to the left. So everything from here all the way to the left. So I mean, it includes 0.5 here, the half of this, but then plus this part that represents 0.94. So it's gonna be 0.5000 plus. Then we look for this in the table, 0.94. So we go to the table of normal distribution. Look at z right here. Look at 0.9 here. Z.9. You have to go under 0.4. So because you say 0.94. So 0.9, you go under 4. That is 0.3264. Can you see that? Can you see that
Yes.
Okay, good. So 0.3264. So go and put the 0.3264 and 0.3264. Now you can add it, and that will give you the area you're looking for. Let me write this down so you can solve it. 0.5 plus 0.3264. Now you can get the decimals calculator and add this to, we have, clear this, 0.5 plus, what's a plus sign? Plus 0.3264. Give us 0.8264. So we have, then I'll take it back to where we'll put our answer in. We have 0.8264. Or if you like, you can call it 82.64%. Now, if you are going to forget to put the percent symbol, then you better leave your answer like this, because if you write 82.64 and if you don't put percent, your answer will be wrong. Okay? So this is how to find the area. First of all, you make a chart. And if your chart looks like, so the chart will tell you what to do. Questions?
No questions.
Good. Now let's try another one. Then we can go to, there are many of them, but let's try another one. Say.
Last question.
Yes.
So 0.94, when we had 0.3264 to be, is it gonna be 0.5?
I don't understand your question. Can you say it again? When we,
you know, each side is 0.5.
yes.
Okay, now we have 0.94, which covers the area to the left, right?
It covers only this. It covers only this part. Look at.
Okay. So what we get now is it doesn't cover the rest of the right side, right?
Covered. See, 0.94 cover only this part. But the question says to the left of 0.94. That's why you need to add this part.
Our calculation is based on that area that was covered, right?
Yes.
Okay.
So that means 0.5 plus what we have for the 0.94 together. But if you're looking for only 0.94, that means you're gonna start from here only. But you say to the left of it. That means everything to the left of. Everything from 0.94 to the left. Okay? Hello? So let's do another one. Let's try number, not part A, part B is almost the same thing, because it's say to the right of this. So if you want, I can do it. Then we can try. Let's do part B. Part B, solution. Okay. Solution. It says to the right of 0.65. Excuse me, my mistake. Part B. Make it big. Okay. Solution. The right of 0.6 negative 0.65. Now, when you look at the table of normal distribution, the one we are using, you will see that it doesn't have any negative number. So you don't have to worry about that if you're using this table. And for this table, negative numbers show that it's only on the left side. That's that that your Z is on the left side. That's all. Yeah. Other tables have a different rule. So let's look at this one. Again, the first thing you do is to draw your chart. So you have it chart. I'll go here and write your shape, the distribution. Okay, here. Then put your the x-axis. And I put the mean at the center, sorry, at the center here. This is our 0. Okay, this represents our 0. 0. They say to the right of this. Now, negative 0.65 should be anywhere on the left side. So I'm going to have negative 0.65. And it says to the right of it. So let's put the line that will represent negative 0.65. This is the line right here. This line here represents negative 0.65. I said to the right of it. That means everything from here to the right. So we shed that. Okay. To show that it's everything from the left to the right. Okay. All right. Like I said, if you're using this, you're gonna be more easy. Okay. And faster, but here we're using a different. We're doing it on a computer, so you need somebody who knows how to draw. So we have this. Okay. Right. See, it's just like the other one that we did. So that means we're gonna remember half of this is 0.5. That is half. Then this is the part that represents negative 0.65. But they say to the left of to the right of it, that means shedding 0.65 plus 0.5. So that area will now become again 0.5 plus. Now we'll look for negative 0.65 in the table. So again, we go to the table of normal distribution. Remember, it is called area of standard normal distribution, table 5. 0.65, this is 0.6 right here. You go under 5. Under 5, see, 2422. So you have it right here. 0.2422. Now when you add this to your calculator, you're gonna get 0.7422, or if you like, you can call it 74.22% if they ask you to get the answer as a percent. Questions? Any questions? Hello?
No questions.
Okay. Let's do one more on this section. Then we go to the next section, which is as a probability distribution. Let's do part C.
Let's do those one between. Let's do the between, the one that has two numbers to figure out.
Okay, okay, let's do the between then. So that's the one you choose for, because I want to do one more. So which one do you choose, D or E?
D, let's do D. D and E are the same. Let's do those.
No, actually, they're not the same. Because this one, they're not the same because this one is negative, this one is positive. So, but we're going to do, we're going to do this part. Remember, we're going to do this part. So this part is the same as this part. Here they call it area. Here they call it probability. So it's the same thing. So you know what will happen? Let us do this one here, BD. Then when we want to do this side, we do a one that looks like E. Okay? Okay?
Okay.
So that, see, this one and this one are the same. Just as here they use words to ask the question. Here they use symbols. Okay? But they are the same thing. Here they call it area. Here they call it probability. But they are the same thing. Okay? So in that case, so let's do this one. And when we come to this, because in this session, we do only two questions since we have done this part. So we do one question here, and the second question will be the one that looks like this one. Okay? Let's do D. So solution, again, you begin by drawing your chart. Whatever you have on your chart will determine what you're going to do. Okay? You make your charts. And then you have this here, the x-axis, and then you put your mean. Now they want between 0.87 and 1.28. This is, remember, this is here, this place is 0. So we have a 0 here. 0, okay, 0 here. I'm going to bring this down a little bit. Okay, bring this one down. Okay. See, it's our 0. And they say between 0.87, 0.87, both of them are positive. That means that they're on the same side. So you're going to have 0.87 here, 0.87. And the other one will be 1.28, 1.28. So you say between them. So we're gonna have say insert. Let's put our lines to show them that the line that this line would show 0.87, and this one showed 1.28. Can you see that? It said between them. So that means we shared between them. Okay, we share this. Okay. Our sharing gonna go like this. So the sharing part is the difficult part, because if you're doing it in the computer, you gotta take time. But with a pencil, you can just share the whole place with a pencil. It doesn't take that this long. But at least you get the point, though. Am I right? Hello.
Yes.
Yes, Professor.
Is it because it's just Saturday? You guys are still sleepy, right?
Professor, we didn't even talk about that we won. No.
Which one?
The election now.
Oh, you won. Don't worry, we have plenty of time to talk about it. Okay. Now look at this. I want to show you this.
So my question is this: how do you know? Like,
we have to put 0.87 and 1.28, right?
Like, yeah, where to put them? Yeah.
Because they are positive. Put them anywhere on the right side.
Oh, okay.
So we don't have to measure exact distance. You don't have to measure it, but you know that 1.28 is bigger, so it will be on the right side than 1.87, right? 0.87 is smaller, so it should be closer to 0. See what I mean?
Yeah.
0.87 is smaller. It is smaller than 1.28, so it should be on the side that is closer to 0. So 1.2 is right. So because they are in the same side, they are positive. Put them anywhere.
So,
you don't have to measure the exact distance. Okay.
Now, why do we have 1.28 when the whole curve is 1?
Well, look at this. Are you watching me?
Yeah.
Half of this is 0.5.
Okay.
Half of this is 0.5. That is 1. 1.28 is the z, not the area. Okay. 0.5 and 0.5 are area. If you add them, give you 1. But here, this is not the area. This is the one. This is 0.87. This is 1.28. They are different. That's why you are trying to find the area. Okay. Are you following? Hello.
Yes. Yes.
So 1.28 is not the area. You see what I mean? It's not the area. That's what we're trying to find the area. The area is total area is 1. That is 100%. 1.28 is not the area. It is a z. So we're trying to find the area now. Okay. So we have our area as. Now, if you look at this chart, you see that it's different from what we had before. This one passed through 0, right? From here all the way to the right. If you look at the other one, from left all the way. But here, they did not even touch 0. They're just between these two numbers. Am I right? Am I right or wrong?
That's correct.
So if your chart looks like this, what you're going to do is this. Find the area of this one. Find the area of this one in the table. Then subtract your answers. That will give you the answer. So let's do it. 1.28, the area from the table. 1.2, you gotta go to 1.2. This is 1.2 right here. Yeah, you go under 8. See 8 is on this side. So 1.2, 1.2, you go under 8. 0.3997. So let me write it down. 1.2 is 0.3997. Am I right? So you go here and put it 0.3997, 0.3997 minus. Now let's look for the area for 0.87. So you have 0.87, that means 0.8 under 7. Look at 0.8 right here. You go under 7. See right here, right here. 0.3078. 0.3078. So we'll have it right there. 0.3078. So you subtract them to get the area. So in our decimals, we have 0.3997, 0.3997 minus 0.3078, 3078. Like a 0.0919. I'm writing down 0.0919. Now we go and put it right there.
0919.
If you like,
okay,
can call it.
Professor, I have a question now. Are you listening?
Listen, I'm always listening.
Yeah, that calculator doesn't have variance.
Which one is that?
The calculator, the Desmond calculator doesn't have variance.
It does. I think, but what you're gonna do is after watching a YouTube video how to use this decimals online, it has everything. Okay.
Okay, maybe I should watch on my own calculator to maybe it's somewhere.
Which one you can use? Which one you are using? They are check online for how to use the variable, get the variable using that calculator you have. It will show you. There are some videos on that. I will show you the calculator and they will be doing it and you'll be seeing it. Okay.
Okay, because I have one on my computer too. All right, yeah. Thanks.
Welcome. So now, any question before we go to the next part? See, like I told you, this part they ask the question as area, but this part they ask it as a probability. They mean the same thing. Okay. So any question on what we just did before I go to the next one? Okay. You guys must be really missing your weekend. That's understandable. Yeah, nobody wants to talk today. All right. Since there's no question, we move on. It says find the probability for each using the standard normal distribution. So because I have done some part of this on the other side, so I'm just gonna do only 2 here. I remember I mentioned. Let us try this one. This type that is at the then after that I'm gonna try this.
Negative, the one on the negative side.
Yeah. See, can you see this? Can you see my hand here?
Okay, on D, right? On D. Okay, on E.
Yes. It has 2 sides. One is negative here. So we're gonna do one of this and that. Then we'll now see how to do the opposite. Okay. So let's choose one. Let's do this one. I'm gonna make it bigger. And okay. Let's look at part C. Okay. We have it again, like I say, you begin by drawing your chart. Okay. We draw the chart from here. Okay. Right. Okay. Right. Okay. Now we put the x-axis. Then from here, I put the mean at the center where we have the 0. Okay, we have our 0 here. And we're looking for the probability of z. Let me copy it right here. And paste it here. Equals I say greater than 0.28, but let us put 0.28 first. 0.28 can be anywhere on the side. This side is 2.83. Then you can put your line to show that the 2.83 section right here. And it says greater than means to the right of that number. So greater than means to the right, less than means to the left. So greater than means that means from here to the right. So we can put the shading right here. Okay, we shed it. Okay, let me put this right this way, and then get another one. Get another one. It will shed all of them. All right. From here. Then this should go here. Right, until everything is shaded. Okay, one more. I'm going to shed everything. Yep, right here. So this kind of shading, we call it the tail. The tail part. Whenever it is at the tail, whether on the right tail on the or in the left tail, whenever it is on the tail, and if you're using this type of table that I have, or you say this is what they call it, the tail. Okay. So whenever it's at the tail, whether it is on the left tail or this one, this one is on, if it is negative, if this is negative, it will be on the left tail. But it's positive, it will be on the right tail. They mean the same thing, it doesn't matter. So long as it's at the tail. So what you're gonna do is do 0.5 minus any answer you get from the table. Remember, this is 0. 2.38. The whole of this place is 0.5. But you are looking for only this small portion. So to find it, you do 0.5 minus what you see on the table. 2.83. Let's look at the table. 2.83. 2.8 is right here. Sorry, excuse me, right here. My mistake here. 2.8 right here. You go under 3. 0.4977. Give me 1 minute. Let me open my book. 0.4977. 0.4977. Can you see that? 2.8 under 3. Can you see it? Hello. Hello, class.
Yes.
Yeah, I can see.
0.4977. 0.49. So we go to back to our 0.4977. 0.497. So whenever it's at the tail, you subtract. Whether it's on the left tail or right tail. Okay. So write it down. 8. 1 minute. Point. Excuse me. 0.5 minus 0.4977. So you have 0.5 right here. Let's share this much. 0.5. Excuse me. 0.5 minus 0.4977. 4977. 0.0023. Okay. 0.0023. 0.0023. You see? Questions?
No questions.
Good. So we have what do we have here? So now, so you can see now let's try. Remember, I said I'm gonna try example of this type because they are the same. Sorry, Miss I think it's right here. Yep, see, which one side is negative, one side is positive on both sides. The other one is positive on both sides. But this one is positive, one is negative, one is positive. So that example is right here. Between P between this and that one. So this being between negative 2.47 and positive 1.47. So we have our solution right here. Solution. Yeah. Again, the first thing is to make your chart. The chart is the key because it will tell you whether to subtract or to add, you know. So we make our chart first again. We'll have this go this way. Okay. All right, then you put the x-axis. Okay. And you put the mean of 0 at the center. Okay. 0 mean. Now I'm gonna copy this so I can paste it so we can get the answer real quick. Okay. Equal. Now let us put the number that represents these two. One is negative 2.46. Okay. The other one is 1.74. So it will be on the right side, 1.74. So we put the line that will represent them. Okay. This represents 2.46. And this represents 1.74. And they say between them. So you can put the line, put this between them, this shared between them. Okay. So like I said, this graph is the key. The way the graph looks like will tell you whether to add or subtract. Okay. So this is our graph. I'm showing everything. I'm going to show everything. Okay. Okay, we put it all the way up. Then I'm going to put another one. Okay. Can you see that? So do you hello? Hello, class.
Yes, sir.
Last time we have a class, I give you the sorry, there was a class the one you wanted me to send the YouTube link, and I did. Nobody said anything. Were you able to watch it? Can you mute yourself, please?
Yeah, that's why I always.
So did you guys watch the movie there? I mean, the video for that class? Because I sent you the link. Hello? Hello? Hello, class? Miss Owot?
Yes, sir, we're here.
I didn't look at it.
Miss Hunter, how about you? Miss Hunter?
Yeah, I've seen it.
You watched it?
Yes, sir.
Okay. So do you guys want me to put this one too for you, or do I leave it?
You can. That'd be nice.
Okay, good. So I will send you the link after the class, okay? So look at this diagram. We are looking for this area, the shaded part. That means from here to here. That means this tells us that we're gonna add them. So first of all, find the z value for negative 2.46 from the table, and find the z value for 1.74 on the table, and then add the two areas. Okay? Hello? Hello, class?
Yes, sir, we're here.
So negative 2.46. Now, remember I told you that the negative sign is just to tell you that it is on the left side. Okay? So if you're using my table, if you're using a different table, you have to go by the rules of that table. But for this table, the negative sign is just to tell you that it's on the left side, that's all. Okay? So what we do now is to find the area from the table and put them here. Negative 2.46 let's share it, get the table. Sorry, negative 2.4. Give me 1 minute. Negative 2. Let me write it down. Negative 2.46. I will go to the table and negative 2.46. Negative 2. So look for 2.46, because like I said, negative sign is just to tell you it's on the left side. So we're not worried about that. So look at 2.4 under 6. 2.4 is right here. You go under 6. Okay. See, 0.4931. 0.4931. Write it down. So I'm gonna go to the paper and put it in. 0.4931. 0.4931 plus, so let's go for 1.74. Write it down. 1.74. I mean, it's 1.7 under 4. We go and look for 1.7 under 4. 1.7. You go under 4. Okay, sorry. 1.7 under 4 should be right here. Okay, because this is 4 right there. 0.4591. 0.4591. Now with these two, let me write it down and then we add them to get our answer for that section. So 0.4591. So we can now go to the decimals and add them to get our answer. Okay. Decimals calculator will give us the answer right away. So we have 0.4931. 0.4931 plus 0.4591. 0.4591. Okay, 0.9522. So which is 0.9522. Now we go to our work and put them in our workbook and put them in. So we have equals answer 0.9522. 0.9522, or if you like, you can call it 95.22%. Questions?
Yeah, Professor, if assuming we have negative 1.74 and they were all on the bar on the left side.
That's the type we did. Remember the one we did?
Assuming that the two numbers that was given, the two probability numbers
are negative, right?
Yeah, are we gonna minus the area?
No. If they're on the other side, are you looking at the screen?
Yeah.
You see the one we did before, where they have both of them are positive and the same side. Can you see that?
Yeah.
In that case, we subtract the smaller area from larger area. So if these two are on the left side, negative 0.87 and negative 1.28, we do the same thing here we did here, and we get the same answer. Okay.
So are we gonna minus it too? If they are
Yes. Now the problem is that you are looking at the minus sign as the actual probability. It's not. The minus sign is for the z value. Probability is not negative. Okay. So when they're on the left side, so long as the two of them are on the left side, whether it's negative or positive, doesn't matter. So long as they're on the same side, left side or right side, you subtract the smaller area from the larger area. Okay? Hello?
Okay, but in this case, when it was on the right, you subtracted it. But when we did this one, you added it.
Because they're not on the same side. This one is on the left side.
Oh.
The other one is on the right side.
Okay, got
it. Okay? They're on the right side. So you look at the shaded area. See, you're shading this whole, you need this area. That means you're gonna add these two. Okay? But in the other one, when they are on the same side, it doesn't matter whether it's here or on the left side. We are looking for only those two areas. So you have to subtract these parts that are not included. That's why you are subtracting the smaller area from the larger area. Okay? Okay? Hello? Now,
Okay.
so now let us, so this is how to find the area or probability for the Z when you are given the Z. Now let us do the opposite. The opposite says when you're given the probability, how do you find the Z? See, that's what we're gonna do now. So look at this one, for example, say finding specific Z value for a given area. Now I've already drawn the chart. Say this one says find the Z value to such that the area under the normal curve is between 0 and Z is 0.2123. In this case, they didn't tell us which side. Oh, they did actually. They said between 0 and Z 0.212. They didn't say that means it can be on either side. Okay, it can be on the left side or on the right side. But I want to show you something. It says between 0 and this. So that means it can be negative this or so. What you're gonna do is this. They gave you the area as 0.2123. So that's why I have the chart already here. So you look for this 0.2123, not on the side, but inside the table. So let's do it. 0.2123. They find it as to find the Z this time. So let's go to the table. You look for 0.2123 inside the table, not on the side anymore, inside the table. If you don't see it, you pick the one that is closer to it inside, okay? So let's say 0.2123. You start searching. Say 21. I see it's right here. Can you see it? Hello? Can you see it? Miss Owotutu.
Yes.
Can you see it?
Yes.
Then once you see it, you follow it to the left. See 0.5. Then follow it up 6. That means 0.56. So we go back and put it right here. See 0.56. Now, because they didn't tell us whether it is the left side or the right side, they just say between 0 and 0.2122. So that means it can either be 0.56 or it can be negative 0.56, since they didn't tell us which side. Okay? Hello? Questions?
No.
Okay, let's do one more example from this side, then we'll start to work on how to apply this in solving real life problems. Okay? Now, look at this one. It says, find the Z value so that the area under the normal distribution curve is 0.3460. Now, they didn't say it between this and that. They just say they give us the area. Solution, in that case, you draw the curve. The normal curve is going to be like this. Okay. 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 Now we have draw the axis, x-axis. I'm going to move this to the next page so that it will accommodate us. Let me move it to the next page. Have more room for that. Yep. And then you can give your insert the mean of this is 0. 0. Now it says the area, they gave us the area, we're looking for Z. So let me put where you're gonna see the area. We're looking for what? The Z. Z. So you say sorry, let's see. Now the area is given as 0.3460. Now remember, half of this is 0.5. You don't have is 0.5. The total is 1. Am I right? Hello? Hello? Hello, class?
Yes, we're here.
Yeah, we do.
We're looking for the probability of Z of we have equals Z equals what? We don't know what it is. What is it? What is it? Okay. And they gave us the area as 0.3460. 0.3460. So starting from the left to the right, from 0.00, 0.01, 0.02, all the way to 1.0. You can see this one is 0.34, so it's not even up to 0.5. Am I right? Am I right, class? Hello? So because it's not even up to it's not even up to 0.5, that means you're gonna be somewhere on the left side. So we're gonna put the line here. Okay. That means you're gonna be a negative number, Z. Okay, because it's not up to 0.5. Okay, and that's gonna be between 0 and 0.5. They didn't tell us. You just said this, so it's gonna be like this. That's the number we're looking for here. Because from here up, okay, it didn't cross the 0. Did it cross the 0? Because you have it here. You have something like that here. It crossed the 0. Okay. Actually, my mistake. I shouldn't share this part. I'm showing the wrong, because it is not up to 0.5. So I'm showing the wrong place. Okay. So you got it from here down, not up, because it is not up to 0.5. So you have it right here. Okay. All right. Okay. All right. Okay. All right. That's another one. Okay. Let's get it here. So the area now, then let's look for 0.3460 in the table of normal distribution. That will give us the area. Now, because it's on the left side, it's gonna be a negative number. 0.3460. 0.3460. And then?
Okay, Professor. You said it's not up to 0.5.
Yes.
That it has to be on the negative side.
Yes.
But each side is 0.5.
Yes, this side is 0.5.
The other side is 0.5 too.
Yeah, but the total, see, look, 0.5 plus 0.5 is 1. Am I right?
Right.
So if you want to start from 1 is 100%. Am I right?
Yes.
So this is 0.00, 0.01, 0.02, all the way to 1.0 on this side, 100%. See what I mean? Yeah. Okay, so now, let's look for this now. So did that answer your question?
Yes.
Okay. Now let's go to the table and look for it. 0.23. Sorry, I forgot what I was looking for. It's gonna be 0.3460. Yeah, 0.3460. So let's go and look for 0.3460. Like I said, if you don't see exactly the number, you just pick the one that is closer to it. 0.346. Let's say 0.3460. 0.3461. 0.340. So this one is closer, because 0.3461 minus 0.3460 will give you 1. Am I right? Am I right, class? Hello. Hello?
Yes, you're right.
Yeah, because if it can be 0.3438. If you subtract it, that will give you a bigger number. And 0.3485, if you subtract from 0.3460, that will give you a bigger number. But 0.3461 is the closest, because if you subtract, you get 1. So now you can follow it to the left. 1.02. So left is 1.0 and up is 2. So now we can have 1.02, or I can call it negative 1.02. So that's how to find it. You can try the rest at home when you get a chance. Let us take a short break, and when we come back, we start from standard normal distribution. But then before I go, any more question on this one? Any question on that one? Hello, class. So they say that silence means consent. So since nobody said anything, so I believe that means you get the point. Now we can take a short break, come back here, and finish the rest. Yeah. So I see you. I see back here. 2:50, so that we can finish up.
Okay.
10 minutes break. Yeah. Applications and normal distribution. So I'm gonna make this bigger. Okay. And this one, I can make it. And try one example here. And we are done. Okay. 250. I'm so happy to hear your voice. I'm alive. Yes, I kind of need it. I just need 10 minutes break. In the wrong man. So I do have more, you know. Oh, practicing. Yeah. Yeah. I'm like, I'm a big man, like, the big, like, you go, I'm not, you know, trying to justice. Big man, big man, right? Because after the big man, after you know, everybody knows my God is good. If I had a mother, I mean, section by section, of course, the issue is on a lot of so, I don't feel I got to What did I make? Hey. I'm so curious. Hey, let me start you. I'm gonna hear. So I finish this topic so that next week I'll have another topic. Thank God I got here. It's Hunter. You there?
Yes.
Okay, Mr. Janelle. You there?
Yes. Yes, I'm here.
Maria, you there? Maria. Maria is sleeping. She's sleeping. Miss Davis, how about you?
Yes,
Miss
I'm
Davis.
here.
Miss Davis, I told you last time to send me an email to give you makeup. I never see your email.
Oh, I thought you said you were going to email it to me like within the canvas. I didn't know you asked me to send you my email.
Yeah, send me email. Mention what we discussed, the makeup you need. Then I can now reply with the attachment with makeup work. Okay, that's what I was.
Okay.
I was looking for this all week. How
Okay.
am I gonna
Yeah,
send?
I was looking.
How am I gonna
So
send the email when
send it.
I don't know your email, Miss Davis?
No, I thought you meant like email it in the canvas.
Oh, I see. I see what you mean. Okay. I waited. I looked for it. I didn't see it. So that's why you didn't hear from me. But I said
Okay. Well,
I'm gonna
I will
see
send
it.
that to you as soon as the end of class.
Yeah, mention those assignments that you want to make up. Okay.
Okay. All right.
All right. Let's begin. It's time. So now I have given you the background of how to find the area under the standard normal curve. You start with drawing the curve first of all, and then you find the area. Now we're going to look at the applications, but before the application, I want to explain what they call the standard normal distribution. If you can look at the screen, you can see I wrote the definition down so you can see it very clear. A standard normal distribution is a normal distribution with a mean of 0 and a standard deviation of 1. That's what it is anywhere in the world, okay? Mean of 0, it doesn't change. Now, every normally distributed variable can be converted or changed to a standard normal distribution by using this formula here. Z equals x minus mean over standard deviation. So that when you use this formula, that variable will no longer be that variable anymore. It will now change to a z. So where our x is the variable data value, z is the standard score, and mu is the mean, and delta is the standard deviation. So let us use this to see the applications of normal distribution. There are many examples here. I'm going to solve one of them. That you can use that as a way to practice at home. Let's solve this one, number 7. That is big. It says here. Can you see number 7? Hello. Can you see number 7 clearly?
Yes.
Yes.
Let's do it then. So, please, when we finish at home, practice as much as you can. Because I can't solve everything because of we have a short time period in class. Oh, I sent a message about a tutor. There's a tutor message I posted in Canvas. Please, if you need extra help, that tutor is available. His name is Chris. So I encourage you to check all my announcements in Canvas so that you can. This class is maybe challenging, but you don't really need to struggle on it, given the type of resources we have for you. Okay? Okay? All right, it says here,
Okay.
the mean daily milk production of a herd of cows is assumed to be normally distributed with mean of 70 pounds and the standard deviation of 13 pounds. What is the probability that the milk production of a cow chosen at random will lie between 60 pounds and 90 pounds? Now, to answer this question, you first of all have to transform this variable into a normal variable using this formula here. Okay? Then after that, it will now change to a z. Then you draw your curve and follow the same steps that I explained to you before our break. Okay? So let's do it. Part A, let's start with part A. Solution is said that the mean is, we'll have the mean as, let me put it here. The mean is, and the question said the mean is 70 pounds. And standard deviation, delta is 13 pounds. Now, it's a part A says, what is the probability that the milk production of a cow selected as random will lie between 60 pounds and 90 pounds? So there are two numbers. So we have called the first one x1 equals 60 pounds. So I'm gonna change this to sub x. Okay, so 1. Oh, excuse me, a mistake. See, and then x2, because it says 60 pounds and 90 pounds, so you're gonna have s2 and y, so equals 90 pounds. So this s1 and s2 are the ones that you need to transform to a z using the formula. Again, let me put the formula down so you can see the formula again. So once you transform x1, it becomes a z1, and when you transform x2, it becomes a z2. I'm going to move this to next page so that we have enough room. Okay. Transform x1 becomes, so we have it right here. Let us transform x1 first. You watching? Miss Hunter, you watching me?
Yes, I am.
You sure?
Yes.
Okay. So let's transform S1 first to Z1. So I'm going to use this formula. I'm going to take you to another workbook, because since we can't get this put this number in this formula here. So let's use another workbook. So let me write it down. X1 is 60, and our mean is 70 pounds. Standard deviation is 13 pounds. Am I right? Yeah. Mean is 70 pounds. Okay. So let me take you to the workbook where we can put this in the formula. The workbook is I'm gonna open it. It's in the Word again. So it's open now. A new Word. Okay. Okay. So I'm gonna have it insert this. The equation is this: Z1 Z1. Okay. Yeah, you can, I'm sure you can see this. So Z1 Z1 equals, I will put the X1 minus mean. We got S1 minus mean of mu. I mean, it's mu. So let's find it right here. Right here, mu divided by the standard deviation, which is a delta symbol here. Don't worry, after we finish it, I'm going to transfer it to the other one where you can see the large. Let me make it a little bit bigger. So that's that one. Yep, see? Now, so we put our numbers in. Our S1 is 60 pounds minus 70 pounds, which is the mean, divided by the standard deviation of 13 pounds, are equal. To find this sum, we can get at Desmos, get the answer from Desmos and put them in here. Okay. So I'm going to take it to Desmos. We got so have 60 pounds S1 minus the mean of 70 pounds. I'll close the parenthesis, divided by the standard deviation of 13 pounds. We have negative 0.7692. But for Z value, we use 2 decimal places. That means negative 0.77. So I'm going to put it right here. Negative 0.77. Negative 0.77. So I'm going to copy this and paste it in our main workbook, which is right here, where the equation is located. Okay, right here. And I'll make it big so you can see it. Okay. Now, so now if you look at this, it is no longer X, it is now a Z. See, it is no longer S1, it is now Z1. It is no longer 60 pounds, it is now negative 0.77. So we'll do the same for X2 by transforming 90 pounds. Again, I'm going to take you to that workbook. This time we're looking at for Z2, because it says X2. Z2, which is S2 minus mean divided by standards. In this case, S2 is 90 pounds. Okay. So our answer, let's see what our answer will be. I'll go to Desmos. I have 90 minus 70 divided by 13. Okay. So let's do it in Desmos. So we got 90 pounds. Come on. 90 pounds minus 70 pounds, that's the mean, divided by 13, which is the standard deviation. I got 1.5384. Again, for standard score, we use 2 decimal places. So give us 1.54. So I'm gonna put this in our our table, our workbook. 1.5. I think we got 1.54. Am I right? Yeah, 1.54. Okay. A table of normal where we are doing our work. Okay. Again, we have transformed 90 pounds. Okay. Now it is no longer X2. It has now changed to Z2. It is no longer 90 pounds. It is now changed to 1.54. Now they're asking for the probability that the milk production is between 60 pounds and 90 pounds. That means between negative 0.77 and 1.54. So let's put it this way. Well, for the probability that's between negative 0.77 less than Z. Okay. That we some way we find it when I introduce this topic. One that 1.54 and so less than Z, I'm to say, then put less than again.
Professor,
Yes, yes, sir.
can you switch the screen over?
Of them. Oh, I haven't done so yet. Okay. I transformed it. Okay, right here. See?
Thank you.
I pasted
Yes,
this here. Yeah. So it is no longer X2, it is now Z2. It is no longer 90 pounds, it is now 1.54. Now they say find it, find the probability that between 60 pounds and 90 pounds remains between negative 0.77 and 1.54. That's what I was putting before you reminded me that I didn't. I didn't know. I forgot to put it back. So now you can see that it has changed to the type of exercise we did before the break. See, it is not like that, the one we did before the break. Am I right?
Yes.
So now, with this transformation, it has changed to that. And then we can now find the area. How do you find the area? We draw the chart. So let's draw our chart again. We have this chart. From here, goes up, goes down. Okay. Then we put our x-axis. Then we put our mean at the center. And our zero right there. So our zero right there. Zero. I'm gonna make it a little bit bigger so you can see it properly. Make it 16. Okay. And it says between negative 0.77, negative 0.77, okay, and positive 1.54. 1.54. So between them. Okay, let me share it. Put the lines in, and then we can answer the question. So once you transform it, it will be like this area we did before the break, and then we can answer the probability question. And this one is 1.54, and it says between them. Okay, then you have to share it. Share this between them. Okay, this right here. Here. Right here. The shading part, like I said, is usually easier when you are using hand. That's why I still miss in class teaching, because COVID-19 put everybody at home. You know, so if it is on the classroom, you see the drawing will not even take this long. I'll be done with it. But we do make do with what we have. Okay. Okay, let's see. Two more, and we have the other part shaded. Okay, shaded. So see, this is between the two examples. Let me make this bigger. Excuse me. This should be 16. Okay. So between these two, I'm gonna move this zero back. Move this back a little bit. Yep. So between these two, so the shape of this tells us automatically that we are going to add two of them. So let's look at the negative 0.77. Remember, negative sign is just to tell you it's on the left side if you're using my table. Now, negative 0.77, we go to the table of normal distribution. 0.77 are gonna give us 0.7 is right here. You go under, this is 7 under 7. So 0.7 under 7, you're gonna get 0.2794. 0.2794. 0.2794 plus a level of 1.54. 1.54 is right here. Is 1.5 under 4. 1.5, you go under 4. Okay, right here. This is 4 right there at the top. 0.48, so 0.4382. 0.4382. 0.4382. And when you add this to, let me write them down. 0.2794 plus 0.4382. With this most calculator, we can get the answer right away. Okay, have 0.2794 plus 0.4382. give us 0.7176. So 0.7176 becomes our answer, 0.7176. Or if you like, you can call it 71.76%. Questions?
No questions.
Very good. Very good. Now, this is, let's look at part B. Part B says, I'm going to bring it up a little bit. Part B says, what is the probability that the milk production for the cow will exceed 90 pounds? Now, remember, the mean stay the same. Mean is still 70 pounds, and standard deviation is still 3 pounds. So I'm going to put this right there. Excuse me. Mean is 70 pounds. Okay. I'll take it down here. Yes. Solution. So we have our mean as 70 pounds. Again, it stays the same. Mean equals 70 pounds. And standard deviation, delta is still 13 pounds. But now they're asking you, exceed 90 pounds. There's only one thing. Unlike this one where we say between 60 and 90. Here they just said 90. So our x equals 90. So we transform this x, we change it to a z using the same formula. So let's do it. I will take you to the other workbook where we have the formula in. So this time we have only z. So you have z equals x minus mean divided by standard deviation. That means 90 minus 70 divided by 13 pounds. We have it already. So I'm going to copy it and then paste it in, excuse me. Okay. Paste it in our main workbook. Okay. Right here. See, 1.54. Because we know, remember, we have already found for 90 pounds before here. Say 1.54. So now let's transform this by drawing our chart first. I will draw our chart. This from here. So go from here, goes up, goes down. Okay. Then we put our x-axis. Excuse me. Put our x-axis. Then our mean of 0. This is 0 here. 0. So I'm gonna move this up a little bit so that we can have enough room for that. Okay, and move this. I'll move that a little bit. I'll move it up. Okay, this one, I'm gonna move this one. Okay, got it. A little bit down. Yep, this is perfect now. Then draw this to the point. Got it. Now, it's exceed 90 pounds. So it is no longer 90 pounds. It is no longer an X, it is now a Z. It is no longer 90, it is now 1.54. So I'm gonna put 1.54 here. Okay, 0.54. And then put the number that the chart that represents that. Then. So the line that will represent it from here to down. Again, put this shared, say exceed means above 1.5, that means from here up. So we're gonna have share it. Okay. And this will be shaded on the side. Okay, this will be, this is the part that I enjoy doing, shading it. I love it. Because once you finish shading, it will tell you exactly what direction to follow. The place you shaded tells you whether you are going to add or subtract, you know. So this one is at the tail. Like I told you, when they are at the tail, you subtract from 0.5. So this one is at the tail side. It doesn't matter whether the tail is at the left or right. So this, we call this side the tail. Okay. So that means the probability that the Z is greater than, it says exceed 90 pounds means greater than 90 pounds. Greater than 90 pounds, that means 90 is no longer 90, it is now 1.54. Equals, again, like I told you, when it's at the tail, you subtract from 0.5 because half of this is 0.5, this half is 0.5, but you're looking for only this small area. So you're going to do 0.5000 minus, then look for 1.54 in the table of normal distribution. So you go there and look for it. 1.5 under 4, 1.5. See, you go under 4. We have a 0.4382. 0.4382. I have it right here, 0.4382. On the calculator, this was 0.4382, 0.5, 0.5 minus 0.4382, you have 0.0618. 0.0618. 0.0618. If you like, you can call it 6.18%. Questions?
No questions.
Now, this is it. Like I said, I have many examples. Try as many as you want. But before we leave today, let me round this up with what we call central limit theorem. Central limit theorem. What this theory is saying is this. It is saying that when the sample size increases, without limit, the shape of that distribution becomes normal, like a curve. So, and when that happens, the mean of the sample become equal to the mean of the population. And then the standard deviation of the sample become equal to the standard deviation of the population divided by the square root of the sample size. That's what it's saying. So by using this approach, we are introducing two things. This standard error, I mean, it's the sample size n and the sample mean x bar. So it is still the same process, except that we introduce sample mean and sample size. And that will lead us to the new formula, which is here, z becomes x bar minus mean over standard. So actually, this is going to be x bar. I just, but in an example, you see, I'll put them in. Where z is the standard score, s bar becomes sample mean, mu is population mean, and standard delta is standard deviation, and n is sample size. So let's do one example of this and see how you can use it's the same process, just that this time around you're using this formula for the central limit theorem because we now have a sample size. The ones we did before, we didn't have a sample size. See, we have a sample size. So, but here we're working with a sample size. That's why central limit theory comes take place. And let's look at this example here. Let's do one of them. Okay. Okay. Let's do this one that is large. Says go to last page. There are many, like I have many examples that you can try at home, but let's do work on this one. Say there is a large supply of a special energy saving light bulb with the average life of 890 hours and a standard deviation of 50 hours. A random sample of 49 light bulbs is drawn. Find the probability that the sample mean will be less than 1,000 hours. This is the lifespan of how long they stay before they are born, the element will get born out. Okay. So again, we have our solution. So you can see that now we have a sample size of 49. So you say there's a large supply of energy level saving light with the average life of 890. So mean, our mean is 890 hours. Our standard deviation, which is delta, equals 50 hours. And then now we have a sample size of 49. N equals 49. Then for this 49 sample, the mean of that sample is 1,000. I mean the sample mean. So the sample mean character, I can't get it from here. So I'm going to do it on the other workbook and then bring it back here. The sample mean is X bar. So we're going to look for X bar. This please show me X bar. See the symbol right here for X bar. X bar equals 1,000 hours. So let me take it back to our main workbook. That the sample mean is now 1,000 hours. Okay, I'll make it as big as the other ones. Now, so we're looking for this. That means we're going to transform this 1,000 hours. Okay, make this go so I can see the differentiation. Now, so let's do it. So we use the formula for the central limit theorem, which is this formula, because now we have a sample size and the sample mean. So let's do it. So that using that formula, I'm going to write it down, and then we'll go to our book and transform it. Z equals sample mean minus population mean divided by standard deviation over root n. And our sample mean is 1,000 hours. Population, don't worry, I'm going to put these things down. So give me 1 minute. Let me write them on paper so I can, when I move to the other side, I don't have to be going back and forth. Okay. 890, 50 over square root of 49. Okay, now I got it. So let me take you to the other workbook where we can put this in. We have the workbook is right here. So our transformation with the new formula is Z equals, we have the sample mean of X bar is the formula. X bar, so I'm going to put it right here, X bar minus population mean of mu divided by the standard deviation of delta over the square root of n. Okay. Now, when we put our numbers that we have in that our main workbook, we got this equals our sample mean was 1,000 hours. Our population mean is 890 hours divided by standard deviation of, I think it's 50. Yeah, 50 hours. 50 over square root of 49. 49. And then we put, let's get this out, our answer from decimals. Then we can now, I will now transform it, move it back to our main workbook. Okay. So we go to decimals calculator. We have clear this, have 1,000 hours minus population mean of 890 hours divided by a standard deviation of we have 50 hours over the square root of 49. Then we close it. the parentheses, and it will give us the answer right away. 15.4. Z is now 15.4. Let me go and put it in. 15.4. That our Z is 15.4. 15.4. So I'm gonna now I can transform it, move it to our main workbook, which is right here. Okay. 15.4. Now we can now make our drawing, the graph. Okay. All right. We have our graph. It says, so it says find the probability that this sample mean will be less than 1,000 hours. So this is how our graph will be. We go and insert it. From here, have it go here. Then this. Then that. Okay. Then you can now put our x-axis from here. Then put your mean of 0. Okay, that's our 0 right there. I'm gonna put 0. Okay, 0. Let me make it bigger. 16 that we're using. Now I'm gonna adjust this a little bit so that it will accommodate the 0. Okay. Just 1 minute. Okay. In that case, I'm gonna move it from here. Okay, that's better. I'm gonna move this one. Okay, that's better. Then I can move this up. Okay, that's better now. And then draw this down. Okay. Yep, got it. Now, so a seed said that the sample mean will be less than 1,000 hours. So remember, it is no longer 1,000 hours. It is now 15.4. And it is no longer S bar. It is now a Z. Okay? So Z, 15.4. Let's see, 15.4 is positive. So it should be anywhere on the right side, 15.4, 40. Now, let's put the line that will represent 15.40 right here. This is the line right here. And it says the sample mean will be less than that. That means from here, from this side, anything on the left side is less than 15.4. So we shed it that way. Okay. And shed this. Okay. Shed everything on that from that side. So like I said, the shedding part is always my favorite part, because once you know where to shed, you can know exactly what to do, whether to add or subtract, or not, Okay. And also, go from here. Okay. Shedding part is the very, very interesting. So I will have 3 more lines, and then it will be actually 2 more, and it will be all shaded. Okay. I have it from here. Now, when it's in this part, now we're looking for this probability of that Z is less than 15.4 equal. Now we look for that. Now look at that, means we're going to add this part, which is 0.5, plus the part that represents 15.4. With this part we find in the table. So 0.5 plus, now let's go to the table and look for Z 15.4. Now back to our table, you can see that Z 15.4 is not here. See? Hello? Hello, Kalas?
Yes.
Yes.
It's not here. So, but look at this. I want to show you something. This is 3.6. After this place, you can see that everything after that is 0.4999. 0.4999. So, see that? So, and it says here, for Z value that is greater than 3.7, use 0.4999, which means we're going to be using 0.4999 for Z 515.4. 0.4999. So we add this in your calculator using Desmos, 0.5, 0.5000 plus 0.4999. That gives you 0.9999. Am I right? So 0.9999, or I can call it 99.99%. Okay, 99.99%. Any question on this? Any question?
No.
So now let us round up with one example, and then you will be good to go. And then we have to, give me a minute. Say we will be less than, okay, say we will be less than, yes. For instance, the sample mean will be less than 1,000 hours. Okay, good.
So what happens if it's greater than?
Better than, then our chart will be different. It will be at the tail. It will look like this.
So are you gonna minus deduct it from 0.5?
Exactly. If it's greater than, that means you're gonna shade only this part, not this part. That means that case you subtract from 0.5. Okay. Now let me do one example. One more, then you can practice the rest. So we have more. You can try as much as you can. Now the one I'm going to show you is when they can give you the area, and they want, like here says find these specific values. When they give you the Z value, the area, the probability, and ask you to find the Z. How do we apply it? In that case, we use this formula: X equals Z times delta plus mean. Okay. In that case, you're looking for X. That means the delta value. So let's try one example here. It says, I'm going to move it to another page so we can go it out. This will be our last example. And then when you go home, try as many as you can. The more you try them, the more better you get. Okay. It says here, to qualify for a police academy, candidates must score in the top 10% on a general ability test. The test has mean of 200 and a standard deviation of 20. Find the lowest possible score to qualify, assuming that the test scores are normally distributed. So in this case, they gave you the area, that's the probability, as 10% already. And they gave you the mean and standard deviation, but they didn't give you the actual score. So we're looking for, they say, they give us the area, okay, as 10%. We have the mean as 200, okay? So let's see, put it. Mean equals 200, and standard deviation of delta equals, we have 20. And they give us the area percentage already, okay? Probability, okay? Probability of Z as, we're looking for Z. And when they give us the probability of Z, let me put this one. Z, we don't know what it is. What's my mistake? Give me 1 minute. This. We don't know, but they tell us that it is 10%. 10%, or I can call it 0.10. Okay. Now, let us find the Z. Once we find the Z, we can now get our X, which is the the lowest possible score to qualify. We want to get the Z. So to do that, we make our chart again. Let's find our chart first. We have this in this form. Okay, then we have our x-axis. Okay, and our standard, the mean at the center, mean of 0. Okay, let's give us mean of 0. We don't know what the Z is, actually the X. So we need to get the Z. Z, once we get the Z, we can get our X. So let me put a line. So this is the cutoff point. It says that here that top 10%, to qualify, the candidate must score in the top 10%. That means 10% and above. So that means that we are looking for this is the top 10% right here. Okay. Right. Top 10%. Okay. Just like we did the other shading, you can see that all these things are related. Yeah, make a curve, and the curve will tell you exactly what. If you draw the right curve, you know exactly what to do after the curve is drawn. So you have it in this form. One more thing. I think one more, then we have a complete shading. Okay, this is the curve right here, shaded. So he said this is top 10%. Everything below it will be 90. But he said top 10%, that means 90 above, then 90 and below is below the cutoff mark. So this is the top 10%. Let me write it down so you can see what I'm talking about. Top 10%. Top 10%. So I'm going to show you with the arrow where the line that represents the cutoff mark. Sorry, a mistake. The top 10%. So right, see this line here? See where it starts. See? Top 10%. So from here, it means this is 90 and above. I mean, top 10%. Below it is 90 and below. So it's 9 and below. It's 9. So now, let us find our Z first. Now, when it's at the tail, I remember I told you subtract from 0.5. So our Z, we are doing the opposite now. Z is 0.5 minus what they tell us 10%. That means 0.1000. Sorry, 000, because if you look at the table, everything in the table have 4 decimal places. I mean 0.400. Okay, let's find it. 0.4000. If you don't see it, we use a number that is closest to it. So I'm going to take it to the table. We are there. I got 0.4495. No, not it. We got 0.3770. No. 0.40. See, 0.4000. If you subtract this, you get 99 points. That's too far away. So we keep looking until we find, see, 0.4015 minus 0.4000, that will give us 15 points away. This is the closest here. Because if you do, excuse me, let me show you from decimals. If you do clear it, 4000 minus I think it's 3997, right? 3997. That's only 3 points away. But if we do the other one, which is we got 4015. Okay, if you have 4015, clear this. 4015 minus 4000. That will be 15 points. That's too far away. So that's why I say that 0.3997 is the closest to 0.400. So if you follow it to the left, that give you 1.2. And if you lay up 8, see 8. So to the left is 1.2, then up is 8. So that means 1.28. Got 1.28 as is 1.28. With this now we can now find the lowest possible score to qualify using this formula here. See, let me copy it and paste it there. So in other words, the lowest possible score will not be calculated using this formula here. See, now I'm going to take you to our other workbook so that we can calculate it, and then I'll put it back here, and then we are done for the day. So I'm going to put it now. Let me take you to that but let me write down the values we have. We have our mean as 200, standard deviation as 20, and our Z as 1.28. Let's do it. So I'm going to take you to the other workbook. We have X equals standard Z times the standard deviation of delta, okay, plus the mean, okay, the mean, which is X, Z is 1.28 times our standard deviation of 20 plus our mean of 200. Now let's do this in decimals. You got the answer right away. I'm sure that we are about to end. I'm sure you are excited that the class is ending. 1.28 times standard division of 20, then plus mean of 200. 225.6. 225.6. So we got 225.6. So I'm going to copy this and put it on our main work. Okay. Main work was right here. We got okay, equals this. So let me make it a little bit bigger. Oops. So that the lowest score to qualify is, you know what? Let me correct this. I put Z instead of X. So let me correct this. Let me take you back to that place. You're gonna be X, not Z. X equals. So I'm gonna put the right one now. The right place. Okay, it's correct now. The right questions. Questions?
No questions.
All right. In that case, I'll see you next week.
All right, Professor.
Thank you. See you then.
Sure. Have a nice weekend.
You
You too.
too.